Hello geometers and general seekers of truth. Welcome to the video on how to construct a triangle when given three specific lengths. And the only two tools we are using here are a compass and straight edge, because these are the classical tools that were used by Euclid when he first came up with his first 5 postulates of geometry. And it doesn't really matter which one of these segments we start with. I'm going to put some dots on here. So we're given 3 lengths here, and we want to produce a triangle that has exactly those 3 lengths. I'm going to name my longest length here AB, and this is how I'm going to start. I'm going to put a dot right here, or a point right here, and I will call this A. Now, to find exactly where to put B, I'm going to set the needle point of my compass on A and the pencil point of my compass on B, transfer it over, and draw an arc. Now, when I first make this, I have lots of options. B can fit anywhere along this arc that I wish, because you can see that anywhere on this arc is the same distance from A, right? And this is the exact distance that we had measured before we made our construction. So now we take our straight edge and draw a line from A through the arc. Wherever they intersect, we're going to call that point B. Okay? So again, our first line segment is very easy to do. We have lots of options that we can use. Now, I'm going to go with my second largest segment, and I'm going to call this line segment AC. So, using the same idea before, put the needle on A, the pencil on C. Right? We are going to transfer it over here and draw an arc. Now you see, point C has to go somewhere on this arc, so we have some options. We have infinitely many options, but yet they're still limited to somewhere on this arc. We don't know exactly where yet, and we don't want to just randomly pick a spot, so we have to be a little bit more precise. So now we know that we have AB, we have AC potentially made somewhere along this arc, and the only segment that we have left to make is BC. So I'm going to name my third side length here BC. Put the needle on B, the pencil point on C, and then transfer it over to the picture. Again, needle point on B, and then we're going to draw our final arc. Now you see, what we know for sure is that point C must appear somewhere on this second arc that I drew, and it must also appear somewhere on this first arc that I drew. So we can conclude that the only place that it could work, that it would make sense to complete this triangle, is for C to be at the intersection of those 2 arcs. So that's where we are going to locate point C. Now let's complete our triangles by connecting these points. And let me show you why this works. So let's see again. From A to B is this length, which matches up exactly with what I have here on my circle, on my triangle. So we know that this length segment and this one are exactly equal. From A to C is this length here, which is what we used to draw this part of the triangle. So these 2 segments here are congruent. Excuse me. And finally, from B to C is that length, and we also know that it works perfectly when we transfer it over to the triangle. So the last segment also matches. So now we've completed our proof. Not our proof, but our construction, using a compass and straight edge to build a triangle of 3 particular lengths. Now, in example 2, we are asked to use the exact same 3 segments from example 1 and make a different triangle. This time name it triangle DEF, and let's see what makes what triangle ABC different than triangle DEF. So I encourage you at this point to hit the pause button and try to figure this out for yourself. Just replicate the process, except maybe go in a different order. Maybe make the second line segment first, or the shortest line segment first, something like that, and see if you can produce a different triangle. Then be honest and actually try it, then hit the play button again, and I'll show you what happened when I did it. Alright, so what I did was I started by making the second longest segment first, right here, you can see that, and then I made the remaining two segments. Okay. And what we have from the picture here is that the way that I made it, AC is exactly congruent to DF, and let's see here, BC is congruent to DF, and then AB, which is the longest one, was congruent, whoops, this should only have one congruent mark, is congruent to EF, right? But at last, if we were to compare this to the original one, it looks kind of the same, because it in fact is the same triangle, right? So if we turn this triangle here, I made this on wax paper so you can see clearly through, you see that the second triangle that I made matches the first triangle that I made exactly. And no matter how you draw this, I can definitely find a way to get the two triangles to match up exactly. So this is a rather not so surprising result, because when you have three lengths, you can only really make one particular triangle. And in fact, when Euclid first did this, he realized this was always true, although we can't quite prove it, so it's what's known as a postulate. So we'll continue with the rest of these notes here in this section, and our discussion will center around a postulate known as the side-side-side postulate. Side-side-side postulate. Right. So I will leave it there for you to take and look at the rest of the notes. As always, ask for help if you need it. Thank you for watching, and have a wonderful day.